This is example problem number 5, and we've got two objects. We have the sun, and we know the mass of the sun will be ms, and the mass of the earth will be m little e. The distances here are not the distances between the two. The distance that we're going to talk about, the distance for the sun is actually the radius of the sun, and then the distance of the earth is going to be the radius of the earth. And so you have to be very careful that you understand that before we begin. It says in this problem that the sun has a mass that is 333,000 times. So we'll say the mass of the sun is equal to 333,000 times the mass of the earth. And they also tell us that the radius of the sun is approximately 109 times the radius of the earth. They want us to find out what is the value for gravity for the sun if we approximate the gravity for the earth is about 10 meters per second squared. You can use the equation. We know that g is equal to the mass of the, well, we have to use the universal gravitational constant first, times the mass of the sun all over the distance for the sun, or the radius of the sun, squared. Let's go ahead and plug some of our numbers in and kind of see what we get. If we want to go through and really set up something kind of slick, there's an easy way to do this without plugging all the numbers in. And in order to do that, we're going to say that this is gravity of the sun, and GE is gravity for the earth, and that'd be big G times the mass of the earth all over the distance for the earth squared. So now we have a couple of different equations. Let's look at the gravity of the sun over the gravity of the earth. The gravity of the sun divided by the gravity of the earth will be equal to, now kind of watch here, this would be the gravity, universal gravitational constant, times the mass of the sun over the distance of the sun squared, divided by big G times the mass of the earth over the distance of the earth squared. So now we've set up a proportionality. If you look really carefully, you'll notice that we can cross some things off. The first thing we can cross off is big G. We know that it's the same on the top as it is on the bottom, and so we can just get rid of those. Let's also go back, and we're going to substitute in for mass of the sun. We're going to put in this number, and for the radius of the sun, we'll put in this number. So notice I have mass of the sun is 333,000 times the mass of the earth divided by, and here's the distance of the sun. We can say this is 109 times the distance of the earth, and remember this unit is squared. That unit's squared. We're going to divide that by what we already have on the bottom, which is the mass of the earth over the distance of the earth squared. If we go through and do some math, we can cross off the mass of the earth on the top and the bottom. We can cross off the distance of the earth squared on both the top and the bottom. And now we're left with 333,000 on the top, and on the bottom we're left with 109, and don't forget the square there. If you go ahead and do that math, you should end up with a factor of 28, which means that gravity on the sun is approximately 28 times gravity on the earth. And if we know gravity on the earth is about 10, so we can get rid of this and just put 10. 28 times 10 is 280 meters per second squared. And that's a little bit easier way of solving for the number instead of using all the large numbers and maybe making a math mistake going through.